Here we go. Okay. So you might notice that the title is slightly different from when it is in the abstract, building an open API from TypeScript. I think you're going to find it interesting, and it's cool that the previous talk was about monorepos, because monorepo is a big topic in this talk as well. So before anything else, let me tell you a couple of facts about myself. My name is Javier Velasco. A few years ago, most of my work was front-end, and I wrote a library for React Material UI kit for React called React Toolbox that I abandoned. I'm sorry if you ever used it. And I joined Vercel quite a while ago when it was still site and we were only like 10 people. That was quite a journey. Therefore, I spent quite a lot of time working on our API and our tooling. So in case you're not familiar with what is Vercel, Vercel is the fastest way to deploy front-end applications. We enable collaboration by giving front-end developers comprehensive tools to build high-performing websites. Our mission is to build a web faster. With Vercel, you can connect any repository from any Git provider and instantly generate multi-cloud deployments that are globally available through our Edge network with every single Git push. But also, you probably know Vercel for being the authors behind one of the most popular frameworks today, Next.js. So let's jump straight to it. And let me tell you what this talk is going to be about. I'm going to be pretty much sharing a story with you. It's a story that starts with the crazy architecture of microservices and culminates with the automatic generation of an OpenAPI specification after incrementally changing our architecture, creating a framework and some tooling around it. It's the story of how we shaped our API and improved our internal developer experience while removing thousands of lines of code, boosting our productivity and making us a much better team. So let's get started with it. Before anything else, let me talk a bit about the OpenAPI specification, because there might be people that are not familiar with it. So the OpenAPI specification is formerly known as the Swagger specification. It's an API description format for REST APIs. And it is the most broadly adopted industry standard to describe REST APIs in a machine-readable formal language. It includes what are the available endpoints and operations in the system, what are the parameters for each operation, which authentication methods are supported, metadata like contact license of authors, and so on. But maybe one wonders why it's a good idea to adopt it, or why should one use it? The first and most important one to me is that it enables you to do static analysis. Because it is a machine-readable spec, we can analyze it and keep track of changes between different versions of the OpenAPI spec of your specification. Usually, it is used as a design-first tool, meaning that you first think about what is the design, and then you go with the implementation. But in Vercel, we went the other way around. We implemented our API, and then we generated an OpenAPI spec that fits this implementation that we had. This enables you to do very interesting stuff like alerting on breaking changes on PR or unintentional changes in the API in general, or parameters, making a parameter optional, and so on. Second one is that it allows to generate documentation from the spec, automatic documentation. There are plenty of projects to generate interactive documentation from an OpenAPI spec. Usually, you can even generate a playground where you can test out your API just by dropping an auth token and using a JavaScript embedded generated client. For Vercel, this is quite important because our APIs have been public since day one, and we needed to document them manually. Another important reason to use it is code generation. In the same way that you can create a dynamic playground with a docs generation project, you can also generate a client typed that you can reuse across different projects. We have many consumers of our API or own. Like the API is a separated project, and then we have a client that talks to it from the CLI. The API is public, so people want to have their own clients. And also we have the front, the dashboard, which is a consumer of the API as well. So having the ability to generate an updated client that can consume the API automatically is a very big win. So those are the reasons, right? Now, when I joined Vercel back in 2017, we used to have a lot of microservices. It was the thing back then, all the way microservices. The smaller, the better. So every microservice that we had used to have a GitHub repository of its own, one or many people accountable from it, dependencies to a bunch of NPM packages, most of them private packages, a code base that could be written in JavaScript, TypeScript, JavaScript with Flow, and mostly no integration tests between services. And each of these microservices were obviously independently deployable. So in short, we were 7 API engineers with a code base that consisted of approximately 40 different repositories, hosting microservices and sharing code through private version NPM packages, where each repository had its own tooling, conventions, build system, and whatnot. So this was not fine at all. It was really, really painful to bump a core dependency. For example, we had a database client, and we were using that database client in most of our API services. So if we worked on a bump of that API client, that database client, and we wanted to, update all of our microservices, that was so painful to go one by one, updating them and releasing new versions. Sharing domain logic was also very difficult, because the only way that you could do that when you have separate repositories was to have a private NPM package that would be used across different services. And that also brings the problem of versioning, because you release a new version of the domain package and then you have to update all of your microservices. It introduced a lot of code duplication, because say that you want to have a small microservice, but then you want to bring in some small routing layer or some validation for parameters. You don't want to use external libraries because it's very minimalistic. But then you end up copying and pasting that code through different microservices, because what are you going to do? You're going to extract a package and publish a package just for that. You don't do that usually. So you simply go and copy that code. The code base was not homogeneous, like at all, nor in aesthetics, nor in, practices. Like the tooling was different in each one. One was TypeScript, another one was JavaScript, another one had Flow. Didn't make much sense. There was no team visibility because no one is watching 40 repositories. So we were not sure what was going on in each of them. And it was literally impossible to generate something like an OpenAPI specification. You don't even have an entry point to begin with and analyze the whole thing. So we elaborated this wish list of what we wanted our ideal solution to be. It should be a TypeScript monorepo. It should be possible to easily share code. It should be homogeneous across all services in aesthetics and practices. We should have a way to generate minimal roles, so we only deploy what is necessary. We should have a single command to run the whole API. And ideally, we should even generate the documentation automatically. So we decided, okay, let's build everything from scratch, and we started over. Maybe I caught your attention back, but no, obviously we didn't do that. We went with incremental changes, because rewriting a system is literally a recipe for failure. You don't want to do that ever. Never rewrite stuff. Go incrementally, changing your system. So how can we get there? Obviously, first thing that we have done is we got all of our microservices and we moved them to a single repository. So now we ended up having something like a folder called API, where we were dropping all of the microservices by domain. So we had, for example, one for deployments, another one for domains, another one for users. And with just that, we have a monorepo. Everything is in the same repository, a monorepo, right? But it's obviously lacking a lot of stuff. So we added a package JSON at the very root. That way we could solve one problem of code sharing, but for NPM dependencies. We would configure, we would change all of our package JSON files in different repositories to make them inherit from the root one, so that we can have a common dependencies for many microservices. Like, for example, the database client, which is something that pretty much every service uses. Forgot to mention that in the process, obviously, we moved everything to TypeScript incrementally, but we had to move everything. That was a lot of work, as you can imagine. Well, apart from this package sharing, this NPM package sharing logic, we also needed certain domain logic to be shared, and we certainly didn't want to publish that into NPM. So we had this utils folder that would have point-free utilities, like stuff to manipulate arrays, creating dictionaries and whatnot, but also domain, classified domain logic, like validating a domain, which is something that it relates to our domain and can be in many different microservices. So that's about code sharing. Now, homogeneity, in terms of aesthetics, we included the prettier JSON config for every single service. So now we are going to be using the same aesthetics, the same logic, the same appearance, adding semicolons and so on. All of this controversial stuff would be the same for every single service. But homogeneity is not only referring to aesthetics, it's also referring to building services in a similar manner, like using the same tooling for validating and so on. So this was partially resolving the case for homogeneity. And with this, what we certainly didn't have is a way to generate minimal roles, but it's achievable. A way to lift the whole API with a command, not there either, but achievable. But about generated documentation, no clue, no idea where to start. So to keep moving, let me tell you about the way we were architecting our microservices. We were using a library that is called Micro. We created that one back in the day, and it's an asynchronous HTTP microservices library that simply will spin up a server based on a request handler. The code would look like this. This would be an example. You have a function that receives a request and a response, and then it's doing some handling with the request method and path name for the routing part. And then you can respond using this send helper. That is really simple, really minimalistic. Now, if you think about this, that would be simply an endpoint that starts a server and everything. But if you think about an HTTP lifecycle like request and response, we can start identifying what are the parts that composed this thing and organize them in our code base so that it makes sense and it's analyzable. For example, in the HTTP request, you're going to see that we have the method, it's post. We have a path name, a query string, some headers, and a body. And then the response has a status code, the status text, headers, and body. With this, these are pretty much the components that we need to model inside of a system. You can think of it as if it was a function. If you think about it as a function, you can consider that the method, path name, query string, headers, body, all of that can be part of routing. That is simply a function where you have these parameters, you're going to invoke some operation, some domain logic, and then you're going to end up sending down some headers, body, status, and status text. And that's it. But it's not exactly like that. You could do that, but it wouldn't make much sense. So we usually split this into kind of groups. So you can look at the method and path name and reason about it like as routing. That's the routing part. And then you can use the rest of the items there to specify what we can call handling. If you look back at the code that I just showed with micro, you can very easily see there what is part of the routing and what's not. Request that method get, for example, is part of the routing. And checking the path name is part of the routing as well. And it's going to be the same for all of the places where you are activating an operation depending on the path name and the method. So we can rather easily extract some decorator functions and use some functional composition so that we can keep the domain logic in a separate file, a separate module that you can import. And then you can have helpers like with method, where you would pass the HTTP method and a handler. And then you only call the handler whenever the HTTP method that you're receiving is that. And you can do pretty much the same with the path name. So if the path name is users, you would call the handler, otherwise you would not. And the composing logic would be a matter of checking if for each handler it responded or not to the request. So that way you can get these helpers and transform that into a configuration object. So we ended up with this from config function, where you can give an array of descriptors that would tell which ones are your handlers and what is the HTTP method and the path name that they use to activate. That is a routing mechanism. That's it. But the interesting thing is that it would get all of this stuff that is static and it is analyzable, and you can transform on the fly. And it's going to convert that into a handler that lazily evaluates the handler functions and starts a server that is composed by a single handler function. That also means that you can get that configuration and extract it into a single object, static object, just like that. So we ended up with this folder config, where there is a routes.ts file that shows the configuration of our API. In there, we would have something called a framework in our repository. That is what hosts the logic that would allow you to say, start a server based on this configuration. And it will read that configuration file. It's going to compile it. We could use ESBuild, SWC, NCC, any other compiler, and then immediately run that code. And what is very cool about this is that you can enrich it. For example, you can see there that handler is an array with 2 different handlers. There is a way to compose it. Handler could be simply one handler or an array with many handlers, where all of them are going to join together and be checked one after another sequentially, like a routing cascade. And then you can add extra stuff, like, for example, tagging to label a service. So you can group a bunch of endpoints and say, this is the user's API. And then based on that, from the framework, you would decide what do you want to run exactly. One endpoint, many endpoints, one service, wherever you like. And not only that, but because it is static and it is analyzable, you have the ability to easily create a piece of software that can run a server for one service, like you see in the first one. It will also allow you to build that service. So instead of running it, you generate a binary or a JavaScript file that you can run with Node, and it just works bundled. Or you can even expose a tracing function that would basically tell you, get me all of the modules and all of the files that are being used for this service. So what are the files or dependencies that I need to use when lifting this thing? And you can even have a CLI command to run it, each of those commands. So with this, we ended up creating a framework that works from a command line in Node.js, can run and shut down services on demand, traces the dependency tree of every service, and allows you to build services independently to be distributed and deployed as microservices while you preserve the ability to have them all together running in a single server that is lazily evaluating each of the handlers. So it starts real fast. And it also allows you to statically analyze all entries in the system. Now, if you jump back to what we had before, we were calling all of this handling. And it's pretty clear that the final part, code body and headers, can be traced and analyzed using send in micro, right? And the operation is your domain logic. But then you also have the input, headers, query, and body. What do you do about that input? How do you analyze that so that you can statically see what are the parameters that your operation requires? And for that, we pursued the perfect validator. What would be the perfect validator? Many of you probably are familiar with AGV or with JSON schema, which allows to define a set of rules to validate JSON structures. So ideally, we should be able to describe what we want to validate with that, but it has a big caveat, which is that it doesn't play well with JavaScript with TypeScript by default. So we want to have this, we want to be able to describe rules in a serializable manner. We also want to be able to easily define nice default error messages and type automatically the validated output with TypeScript and make all of those errors customizable. So we found about this other package, JSON schema to TS, which is really cool and basically allows you to get JSON schema and infer the type that it would generate once it goes through a structure and validates its accord relating to the config that you just passed. So we ended up with a validation tool that looks like this. It's simply a function where you say, this is an object. I want to have, it's an object that has a team property. The team properties require that holds an object that requires a name, blah, blah, blah. And that is going to automatically get you an interface that exactly matches that type. So you have the best of both worlds. You have a way to statically get rules, and you also have it integrated in TypeScript, so the code will ping you when something is going wrong. So running back to our wish list, we now had this TypeScript monorepo where we can share code, and reusing these utilities like validation and so on, it was actually homogeneous. So now we can also have minimal roles. It's actually pretty easy because every time that we want to deploy something, we can diff what we are changing and trace every single service. So we would see the file that we are changing, what is exactly affecting. So that would allow you to deploy only what you need. And we also have a single command to run the whole system. You just do framework run, and the whole thing starts a server, lazily evaluated with the whole API. Now, generated documentation is still something that was missing from this. How do you do that? And the truth is that we have TypeScript. Everything is written in TypeScript in our monorepo, and everything is related and is using common tooling. So for when you are at this stage, it is actually not that difficult to analyze everything because everything is statically analyzable. So we can use something like tsmorph, which is an AST parsing used for TypeScript, and trace all of our helper usage. So you can see exactly the places where you are calling validators correlate that with each of our microservices, and then read what is the JSON schema input that we are validating. And that way you can infer the parameters. So if you look at it from the OAS specification gives you and what the framework gives you, you would see that we have endpoints of methods that can be expressed in the routes manifest. We would also have path and query parameters in the specification, but we have a validation wrapper to validate queries. So we can get it from there. We have header parameters, but you can also validate it using a wrapper to extract headers whenever you need to use them. Responses can also be traced and analyzed by looking at the usage of the send function in micro, or whatever each handler is resolving to. And metadata can be added by enriching all of our functions, each of our wrappers and each of our handlers with JSDoc. So in the end, what we have are handlers, that one for each of our domain logic, and they look like this. We have a comment that describes what the operation is doing, a summary, an operation ID for future generated clients, tags, and then a validator. And finally, when we are responding, we can also label if what is the response representing and each of the parameters that the response has. That response is going to be also typed because we are using TypeScript, and we can analyze what is the type that is being sending. So with this, we generate the whole spec, which allows us to get this documentation. Well, now it looks quite different from this, but this was like the first prototype where the whole thing, the whole documentation is automatically generated from the implementation of our system. And I think that is pretty cool. Now, for real, we got everything that we wanted in our wish list marked. And we can do more stuff that is very cool. For example, we had this GitHub action that if I change an API endpoint, like for example here, and then I send up a PR, is gonna generate the previous OpenAPI spec, the new OpenAPI spec, and it's gonna compare those two. And it's gonna see if I am changing it. So the action is gonna tell me in a comment that the PR is changing the contract of the API. And that way you're taking very low the chances of introducing breaking changes or unintentional changes, not necessarily breaking one. So with all of this, if you look in retrospective, you can think, is it worth to build a framework and reinventing the wheel? But I hope that with this story, you've seen that it's not about reinventing the wheel, but it's incrementally building a vehicle to go and take your company where it needs to go. And that's all I have. Thank you, guys.
Thank you, Javi. Can we do clapping emoji in the chat for Javi? And if you have any questions, drop them there. We have plenty of time to chat about all this stuff. But I'll start because
I'm sorry, I'm not sure how long it took actually, because I wasn't like measuring. I hope it wasn't too short or too long.
No, we're good on time. Don't worry about it. So any big sort of like migration like this, or like really beefing up tooling and stuff like that, I feel like there's probably lots of opinions that get thrown in the mix. How did you folks manage to sort of decide on approach and on goals?
Well, usually, when evolving this whole thing, there was like a big goal at the beginning. We had this super distributed system, and at some point we were thinking it would be very nice if we have one command to run the whole thing. so that we
Which,
can
like classic Vercel move, make it a CLI command.
Yeah, it's always a CLI command, right? Very classic. So we usually like can get started with that goal, which is very ambitious. Like when you are at that stage and you say, let's have a way to containerize our API, deploy it and test it all together. It's like bananas. It's crazy. How do you do that? No, and go there incrementally. And when you are aiming for a goal like that, there are other things that usually are controversial, like aesthetics and using one prettier configuration or the other, and how we organize everything. But in the end, it's not that important if you compare that to the bigger goal. So usually when it's something important, we brought up a thread in Slack or something, like how everybody feels about doing this thing or going this way. And once everyone agrees, or most of the people agree, then we can move forward. Adopting TypeScript is one of those things that we never, as far as I can remember, we never said out loud, let's move everything to TypeScript. But looking at the scene, we were thinking, it seems like TypeScript is the best way, to do this. So let's incrementally go there. There was no task moving everything to TypeScript. But you move one thing, you change it, then you move another file, you move it as well, go step by step. And then at some point you're like, we're almost there. Let's get it done. And you get it done. So I can't recall many controversial decisions that require a long conversation, but generally they lose, how would I put that? Like it was many of these controversial things that are like terrible people discussing on Twitter, like, it's not that important in the end. So yeah.
Right. And similarly on that line, Miro asked, how many failed approaches led to the right one?
Well,
is there anything to drop entirely, or
I can't think of something like specific that we started working on and then at some point we're like, oh, this is not going to work, and then taking one step backwards. I can't really recall on any of that, but I do remember, if it's worth mentioning, that when I joined at the beginning, the Flow versus TypeScript battle was still there, and we had some people pushing for Flow. I wasn't, for the record. I was pushing for TypeScript. But we had this battle, and at some point we're okay, let's do everything in Flow. And I got very frustrated because I needed to work in some microservices and move them to use Flow, and I was very annoyed by that. But other than that, I can't really recall taking many decisions like that. Yeah.
My office is a Flow shop, and about once a month somebody goes, hey, what if we migrate to TypeScript? And everyone goes, that sounds hard, and then ignores it and pretends it's not an issue.
Yeah.
Michael asks, and slightly off topic, but it's on the wall, do you consider OK Computer to be the greatest Radiohead album?
Oh, I can't. Like, it's Kid A, OK Computer. They are both 11s over 10. So
do you think OK Computer has better album art?
What? Sorry, again?
Do you think OK Computer has better art
than Kid A? Yeah, maybe. Kid is pretty cool too. Yeah.
Impossible question.
But I mean, it's impossible. Who do you love more, mom or dad?
Michael is satisfied with that answer. Good answer.
Cool.
That GitHub action ping the change thing was very cool. Can you talk a little more about that? Is it still something that you use?
Yeah.
Is it a lifesaver?
The story is actually that we hosted like a small hackathon, internal hackathon, to build something that you feel like was cool, but we never had time to build. And I had this OpenAPI generation project half-baked, and I was seeing very clearly that it wasn't going to be that difficult. And I started digging into some open source solutions to compare OpenAPI Spec and JSON schemas between each other, and telling you which ones were breaking changes and just, pulling out what was simply changes. And they were there. So I proposed that we could try to do something like that for the hackathon, like generate, because we already had most of the work already there. It was a matter of figuring a way to generate, what was the best way to generate a client automatically typed in TypeScript and whatnot. And yeah, like finding a tool to compare. So in the end, the GitHub action is the thing that is wiring everything together. And it wasn't that difficult. We already had an action to generate automatically the spec on the fly and deploy it to Vercel. So it was a matter of copying the same action for the upcoming changed API version, and then another one to read from cache a couple, those two implementations, compare them and print a comment. It wasn't that difficult. The hard part is to be able to, grab all of the changes and generate this spec. That is the difficult part. Once you have that, it's all way there. Yeah.
And what's the next big thing?
Next big thing. Well, the next big thing for me in particular, was Edge middleware in Next.js and the Edge functions infrastructure. We are very hard working on it. We have many things ongoing right now. One of them, and what I'm particularly focused on, is getting Edge middleware in Next.js to GA and bringing support for general purpose Edge functions and non-Next.js middleware. That work is ongoing, should be there very soon. Yeah.
Attila says switchable runtime on Next.js. Want to talk about it?
Yeah, works ongoing. Yeah, it's interesting. I wouldn't, we are in conversations. I wouldn't approach a switch to change the runtime for the whole Next.js project. I think I don't like it that much. Like, you probably will have some peculiarities depending on the function that you want to run. Some things are more interesting to be in the Edge. Some others are better at static. Some other might be better in Lambda. Well, not better in Lambda, but maybe you want to use a different runtime, So yeah.
And what's the feature that you like personally and emotionally would most want to see? Is it the Edge or is it?
Well, it's Edge. Like, definitely, it's where I put most effort. Apart from all of this tooling that I mentioned in the call, that in the talk is where I'm putting a lot of effort, and I've been putting a lot of effort on it for the last few months, like 3-4 months or something. And I particularly started most of the work from scratch in every vertical, and that was very challenging because there are many things to consider: deployment pipeline, Next.js, how we build, how we deploy, how we request on demand, serve traffic, caching. There are many sharp things in that project. And I have a special love for it because I worked a lot on it. And I hope to be working a lot more on it to get it killer and perfect.
That sounds really cool. And maybe once you've done that, you'll find out you need a whole new set of tools, even. Yeah. Howie, where can people find you on the internet?
Say again, sorry?
Where can people find you on the internet?
Where can people?
If anybody wants to learn more or
chat
to you.
Absolutely, ping me. I think I had my handle was in the first slide. I don't know if you catch it, but if not, my name, that's it, Javier Velasco. More than happy to get into conversations and so on. Where can people? Yeah, okay, working people. That's what I understood, sorry. Oh. Yeah, just reach out. I'd be more than happy to talk about anything.